Because there's another example I want to do. Okay. Then we'll move on to chapter 11. Okay. So for this one's another one. We have a bunch of students, okay? These students took the exam, that is, okay? It's out. The exam is out of 100, and we presented the scores here. And again, just like with the other one, right? Here we're looking at all scores greater than or equal to 0 and less than 5. So if someone got a 1 or 2, those students, the number of those students that got greater than or equal to 0 but less than 5, that would be here. There would be 2 students whose score is in this interval. Here, right, there's 2 students who got an exam score greater than or equal to 10 but less than 15. So the question now is, how many students took the exam? And what percentage of the students got a 70 or above? Well, really, to see how many students took the exam, right? It's just like what we did before. We have to add the frequencies. You could almost think of it as if they asked each student their exam score, and the students gave their honest answer. So just like with asking the parents, just like with the example here, asking the adults how many kids they have in their families, right? We added up the frequencies. So we're going to get, it looks like 2, 2, 1, 2, 1, 2, 2, 1, 2, 1, 1, 1, 1. So it looks like if we did that, it looks like we should get 20. So that's how many students they asked. Again, all we did was we added up the frequencies. Over here also, what percentage of the students got a 70 or above? So what you want then is you want to look at the frequencies for scores that were at least as large as 70. In other words, we're going to look at this bar, right? So bigger than or equal to 70. We're going to look here as well. So what we're going to have is we're going to have 1, 2, 3, 4, 5. And 5 out of 20 is, again, times 100, that's 25%. No, sorry. If you do that calculation, you get 25%. Okay. Any questions on this? Okay. So that's it for chapter 10. Sorry about that mistake that came up. And what slide was it? In this slide. I don't know how I overlooked that. Unless maybe this should have been maybe one student. Or one child, I mean. Oh well. All right, let me share the other stuff. Here we go. Okay, here's chapter 11. We're going to look at, again, we're going to look in chapter 11 now. Okay. Okay, so here, what we're going to look at is distributions first. There's a few different things we're going to look at here. For one, we're going to look at describing the data. That's what we're going to look at. Basically, in this whole chapter, that's what we're going to look at. We're going to describe a distribution. We'll see what a distribution is. You'll actually see it's really based on histograms and frequency tables. So for the most part, we're going to be working with quantitative data, although qualitative data will come up a bit. So we are going to be working with histograms. We'll also look at measures of central tendency Basically there we'll see, okay, what do they mean by the center of a distribution? What could that be? There's different ways of thinking about it, and we'll see that. That's actually probably what you thought of when I said we were going to look at statistics, like mean, median, mode, that kind of thing. There's also variation we're going to look at. That has to do with standard deviation and variation. That's basically how the data varies, hence the name, hence measures of variation. So there's also quartiles we're going to look at, and another kind of graph we'll see, which is box plots. Okay. Well, what is the distribution? Well, by definition, we looked at variables, right? Quantitative and qualitative. Well, the distribution of a variable tells you all possible values the variable can take on, and the frequency associated with each as well. That's what distribution basically is. So really, when we looked at those frequency tables from before, we were considering distributions basically. We were, like for test scores, for instance, that what we saw a distribution of those. And really, to deal with this, we like to look at frequency and histograms to show a variable's distributions. As I wrote down here, there are other methods to consider to present a variable's distribution. There are other ways of doing that. For the most part, though, I want to focus on frequency tables and histograms. Sometimes you can think about drawing a curve I don't want to say in the histogram. I mean, the book has better pictures, but you can imagine drawing a smooth curve. That can also help display the distribution of a variable. That can also help. So really, we're going to see a lot of histograms here and frequency tables. Okay. That's what a distribution is. Now, there's a lot of different kinds of shapes and properties that a distribution can have. There's a lot of different shapes that a distribution can have. Okay? One of them is a distribution can be symmetric. So this is one of the shapes or properties a distribution can have. To be symmetric, that just means if you were to fold it, its left and right sides. So if you were to fold it about its center, that's better, and its left and right sides would overlap each other. So it's symmetric. Here are just examples with curves. We will see examples with histograms. And I should say this also, as I wrote here. When you say it's symmetric, it may not exactly be images of each other. If you were to fold it about its center, they may not overlap each other 100%. That can happen. So it could be symmetric even though it's not exactly mirror images of each other. I mean, these happen to be. Because here, it looks like the center would be the y-axis. Here, I'm not sure exactly what the center would be, but whatever the center is, if you were to fold these curves about it, these distributions about it, you would get symmetric. They would be mirror images of each other. So this is more like how we're going to see distributions. We're going to see histograms. So I didn't draw a curve here, but we don't have to. I mean, the book does, but we don't have to. But here we actually have, these aren't symmetric, of course. And you can't imagine folding either one of these about anything and the two halves will overlap. This is actually what we call a skewed distribution. As you can see, they're not symmetric. And what happens is the data values tend to cluster, I guess, towards one side. Like here, for instance, when it's left skewed, the data values you can see are mostly towards over here to the right side when you're looking at the histogram. Right? That's what these higher bars tell us. There's more data values here. Whereas over here, the data value tends to cluster towards this side of the histogram. And also the other side here, they call that a tail. And where the tail is, that's what they mean by left skewed or right skewed. The highest value is actually, or the highest bar you could say, is actually what they call the peak. and the tail, right, depending on what side the tail is on, that's what they mean by left skewed or right skewed. Here, for instance, you can see the tail is on the left side because the data is clustering on the right, so it's left skewed. Right skewed, the tail is on the right side, the data is clustering more towards the left of it. It's not like, for instance, here where the data is not really clustering towards anything except in the middle. So this is symmetric. Okay. So that's a skewed distribution. Here's a better example of a symmetric histogram. I mean, again, you can see though that it looks like, roughly, this isn't exact, but you can see that the center would be probably somewhere around here. If you were to fold about this center imaginary, if you were to fold about it imagining, these two halves would almost line up with each other. They're not going to exactly line up with each other, but they almost do. So roughly it's symmetric. You can see it's a lot more balanced out, so to say, than either one of these. Right? Here, the data is clustered on one side, the left side. Here it's on the right side, whereas here it's more towards the middle of it. Okay, I'm not done yet. Don't worry. I just want to stop the recording.